This last part of topic 6, we're going to look at using trigonometry a lot more. We need to go back just a little bit so that we don't forget what we've already learned. And what I'd like you to do now is actually approach these slightly differently from what we did before. What I want you to do is I want you to rename to theta. I want you to call it Z. So that now we're going to find sine Z equals 0.5. Now we've got that 0 is less than or equal to theta, which is less than or equal to 360. If we're actually going to look at 2 theta, is going to go from 0 to 720. It's just something we need to bear in mind. Okay, we can find Z. Z is equal to sine inverse of 0.5. And remembering that sine is positive in 1 and 2, quadrants 1 and 2. So Z is going to be 30 degrees, or 180 minus 30 degrees, which would be 150. Now, we can go all the way up to 720, so we can add 360. We can go around again, so it would be 30 plus 360, which would be 390. Or it would be 510. Okay, we're not looking for Z, we were looking for theta. So if Z equals 2 theta, then theta equals Z over 2. So theta is equal to 15 or 75 or 195 or 255. If we were to draw the graph of that, there's our 360 there. You'd see that we'd have gone round twice, and then the points what we'd be looking for would be there and there and there and there. So we know we need 4 answers, so then we've got ourselves our 4 answers. Similarly, we name 3 theta as Z. Okay, theta was between 0 and 360, so 3 theta is between 0 and 1080. Okay, so we're just going to find Z equals cos inverse of 0.5, negative 0.5 actually. Well, we start off doing it as 0.5, provided we then remember that it's negative, and it's negative in quadrants 2 and 3. So that 3 theta, or Z, would be 120, 240. Then we can add 360, so we'll get 480 and 600. And remembering that we can go all the way up to 1080, so we can add 360 again, and we'll get 840 and 960. Now if we add 360 again, then we get out of range. So that's as far as we can go. Now we weren't looking for Z, we were looking for theta. So if Z is 330, then, sorry, if Z is 3 theta, theta is Z over 3. So theta is just each of these numbers divided by 3. So it would be 40, 80, 160, 200, 280, and 320. Similarly for the last one, tan 2 theta plus 20, call that Z and then solve that tan Z equals 0.3, etc., etc. You'd be looking for 4 answers. Tan is positive in which quadrants? It's positive in 1, all science teachers, so it's positive in quadrants 1 and 3. So you'd find the appropriate Z. You can go around twice. So we can actually go from 20 up to 740, being twice 360 plus 20. And so we'll get 4 answers. Just check that they're in range. You need to make sure that they're all between 20 and 740, and then you're going to rearrange the fact that Z was equal to 20 to 2 theta plus 20. And so the theta was frustrating. Theta is Z minus 20 over 2. Similarly for these ones, the first one you're going to have to shift the 4 and then you're going to have to divide by 7, so you end up solving sine theta equals 4 over 7. And for the second one you end up solving that tan Z equals negative 5 over 3. And for the last one, you'd end up solving that Z was equal to cos inverse of a half. Using the trigonometrical identities that we used before, we can do some algebra and figure out that actually we can combine two expressions providing these bits are the same, and we can rewrite it as r sine omega t plus alpha, and we work out r as being the square root of a squared plus b squared, and alpha as being the inverse tan of b over a. And we just need to think that this is our horizontal measure and that is our vertical measure, and we can draw that in a diagram like that. And 4 was our vertical, 3 was our horizontal, and we can work out then that the hypotenuse is 5. And in this case, we can work out that it's got to be in quadrant 1, and that r, well, we've actually worked it out, r must have been 5, and alpha must be the inverse tan of 4 over 3, And if we're in degrees, that would then be 53. Or if it's in radians, it would be 0.927. So that means that 3 sine omega t plus 4 cos omega t could be rewritten as 5 sine omega t plus 0.927 if we're using radians. That would then allow us to draw both of them. The dashed one is 3 sine omega t. The dashed and dotted is 4 cos omega t, and adding them together we get 5 sine omega t plus 0.927. That gives us the amplitude of 5, so it's going to go up to 5 and down to -5, and the time shift is going to be actually the angle shift is going to be 0.927. For a quick diagram first, the vertical is going to be negative, so the vertical is going to be negative and the horizontal is going to be positive. So we're looking at a triangle in there. That means it must be in quadrant 4, that if this is negative and this is positive, then it must be in quadrant 4. Okay, so A is equal to 3, B is equal to -5. That allows us to find the hypotenuse. Okay, leave your hypotenuse as the square root of 9 plus 25, because then it's accurate. It's the square root of 34. Now we need to find alpha. It's the inverse tan of B over A. So it's the inverse tan of -5 over 3. And it's got to be in quadrant 4. So that means when we use our calculators that it's going to be -59.03. So we could rewrite our given equation as root 34 sine theta minus 59.03. Check it out. The horizontal is 2.4 and it's positive. And the vertical is 3.2, like that. So we can find R is equal to the square root of 2.4 squared plus 3.2 squared. And from that crazy number, actually, that comes out as being 4. Alpha is going to be the inverse tan of 4 over 3. And we can already see that it's in the first quadrant. So again, it's actually going to be 0.927 radians. So we can rewrite our original expression as being equal to 4 sine omega t plus 0.927. We could draw our triangle. That's going to be 100. That's going to be 150. We can work out what R is going to be. R is going to be square root of 150 squared plus 100 squared, which is 180. And we can work out what alpha is. Alpha is going to be the inverse tan of 100 over 150, which would be 2 over 3. So alpha is going to be 0.588. So we can rewrite everything that we know. Our voltage, right, we already had the 120 plus, now we're just putting this bit in this sort of format here. We know that it's 180 sine rho t plus 0.588. And it says state the maximum value. This bit is going to be maximized at 1. The maximum value of sine is 1. So then it would be 180 times 1. So the maximum value would be 120 plus 180 would be 300 volts. For this equation, again, we need to find R and alpha. So R is equal to A squared plus B squared and the square root thereof. So it would be the square root of 3 squared plus 5 squared, and tan alpha is equal to B over A, and that would be 5 over 3. So R is equal to the square root of 9 plus 25, which equals root 34. And alpha would be the inverse tan of 5 over 3, which you would look up in your calculator. Just need to do yourself a quick diagram, a quick triangle. In this case, the 3 is the horizontal and the 5 is the vertical. So that's your H there, and that's alpha there. Look at this one carefully before you start. It's written sort of almost back to front. The sine term is the second term, and the sine term has got a negative coefficient. So this is the horizontal, and this is the vertical. So if we're drawing our little triangle, this time it's got a negative horizontal, so you're in the second quadrant. Then you've got a positive vertical of 3.5. So you can see then you're in the second quadrant. So we're in quadrant 2. So R is equal to the square root of, now it doesn't matter actually that is negative 5.8. And alpha is inverse tan of 3.5 over negative 5.8. That gives you the angle in the right quadrant, and using the calculator we can find that is 148 degrees, 89.89. Because this is all decimals, it's not going to be a nice number, so there's no real problem about leaving that as r as being the square root of 45.89. So now we can rewrite this equation as square root 45.89 sine A plus 148 degrees, oops, sorry, 0.89 degrees, and that's got to be equal to 6.5. Starting where we left off, you need to first of all get rid of the square root of 45, so sine A plus 148.89 equals 6.5 over square root of 45.89. And go through the motions of letting z equal A plus that, etc. So then we find out that z is equal to 73 or 106. And that gives us, rearranging that equation, that gives us that A is equal to negative 75.35 or negative 42.43. Really, we needed to have our answer between 0 and 360. So these two numbers, if we add 360 to them, then we get A is equal to 284 or 317. So the first thing we needed to do was rewrite our original equation of 3.5 cos A minus 5.8 sin A equal to 6.5. We needed to write the left-hand side in a more concise form by finding R and alpha, and then go through solving as trigonometrical equations. The first question asks, for how long does the pump inhale each time? Well, the pump's going to stop inhaling when R is equal to 0. So it's a measure of solving 0 equals 2000 sine pi t over 4. Okay, so dividing both sides by 2000 and taking the inverse sine, that's pi t over 4 is equal to inverse sine of 0. So pi t over 4 equals 0 or pi, and 0 is not sensible, so then we can rearrange that to find that t is equal to 4 seconds. The second part of the question says, when does the rate of air pressure with change of air pressure first exceed 1500 milliliters per second? So we need to solve when 1500 equals 2000 sine pi t over 4, rearranging that so that we get, using inverse sine, pi t equals 0.848. And if you look at a little picture of that, it's a sine curve, and it's going to go up to 2000. And so 1500 is down there. And that's going to give us, down here again, that's going to give us a number for t, which is there, that's 1.08. And then by symmetry, it's going to be that the second time it is 1500 is going to be that plus 4 seconds. We did need to work out the time period, but that's okay. We can use the usual formula that T equals 2 pi over omega. This is a different looking trig equation that we need to solve, and what we can actually do is we can turn it into a quadratic, and we need to remember that there are trig identities that will help us do this. So let's change cos 2 theta into 1 minus 2 sine squared theta, and then we can put that into our equation. So now we have that 1 minus 2 sine squared theta plus 3 sine theta equals 2. So now we've got a quadratic. We can rearrange that so that we can say 2 sine squared theta minus 3 sine theta plus 1 is equal to 0. Now that's just a quadratic. Yes, it looks complicated, but you can factorize it just as normal. So we can factorize to 2 sine theta minus 1 times sine theta minus 1 equals 0. Then we can see that sine theta equals a half, or sine theta equals 1. So that gives us that theta is equal to 30 degrees. Don't forget sine is positive in the first and second quadrants, so it would be or 150 degrees. And the only place where sine theta is actually positive 1 is where theta is 90 degrees. So there are 3 answers there.